Anupam sir, am I audible? Sir, you can start streaming now. Okay. Okay. Dear participant and organizing committee members of IWWM 2023, a very good afternoon to all of you. Myself Dr. Siddhartha Shankar Boxi, Associate Professor, Department of Chemical Engineering, Haldia Institute of Technology and convener of this event. First of all, I would like to welcome all of you in this 5 days online faculty development program on Industrial Wastewater Management IWWM 2023, organized by Department of Chemical Engineering, Haldia Institute of Technology in association with IQAC HIT Haldia. Dear participants, because of some unavoidable circumstances, the formal inaugural session of this FDP will be on tomorrow at 3:30 p.m. However, today's technical session will be as per the schedule. Dear participants, the availability of fresh water is decreasing day by day due to the release of untreated wastewater generated from the different sources such as domestic wastewater, municipality wastewater, and industrial wastewater into naturally occurring resources. The development of efficient and sustainable wastewater treatment technology is essential for improved control over the water cycle management and reuse. The wastewater from various industries is characterized by high BOD, COD, organic and inorganic contents. Without adequate remediation, the discharge of this wastewater into adequate into aquatic bodies may result in major environmental problems. Nowadays, government has imposed very strict rules and regulations for the discharge of effluent in order to protect environment as well as public health. Therefore, characterization of wastewater treatability studies and planning of proper units and processes for effluent treatment are very much necessary. Under this theme, actually, we are organizing this event. Now, this time we have received about 290 participants registered from all over India. And in this 5 days faculty development program, we have one lecture each day. The eminent speakers are Mr. Santanu Sen, Senior Manager IOCL Haldia, Mr. Asid Mitra, Deputy General Manager Manufacturing Haldia Petrochemicals Limited, Mr. Pranav Sinha Mahapatra, Senior Manager Utility MCPI Haldia, Dr. Amitabh Bandyopadhyay, Professor Department of Chemical Engineering, University of Calcutta, Srimati Sangeeta Sengupta, Scientist, Patent Information Center. Now, dear participants, some formalities you have to do in these 5 days, like filling attendance each day, feedback link at the day. Feedback link actually you have to submit at the last day only, and have to appear a small MCQ based test on the last day only. And all the links actually we will provide in the chat box of the YouTube live session at the end of each lecture. And that is all about the part actually, and thank you everyone. Now within few minutes we will start our technical session. Please stay with us, and thank you. Dear participant, now we are going to start our technical session. Our today's speaker is Mr. Santanu Sen. Mr. Santanu Sen obtained his BTech in Chemical Engineering from University of Calcutta. He joined IOCL in 2006 and acquired functional experience of about 17 years. His experiences include operations, technical services, and HSE functions at Haldia and Paradip refineries of Indian Oil. Currently, he is working as Chief Technical Services Manager at Haldia Refinery of Indian Oil's Refineries Division. In his present assignment, he is working in process project for ongoing and upcoming projects of Indian Oil at Haldia and its new petrochemical initiatives. Today he will be giving his lecture on modernized effluent treatment plan and hazardous waste management storage and disposal. Now I would like to request Mr. Sen to start his lecture. Sir, please. Sir, am I audible? Sir, please start your piece.
Am I audible, sir?
Yes, sir, you are audible. Please share your PPT faster.
Okay. Is it visible, sir?
Yes, sir, it is
Okay.
visible.
In full screen, it is visible, na?
Yes, it is full screen.
I will divide the entire topic, what has been given to me, in two parts. One is modern technologies of effluent treatment plant, and the second part is the hazardous waste and other waste management transboundary movement rules 2016 and its interpretation, and hazardous waste storage, transport and disposal. So to start with a modern ETP plant, nowadays most of the industries are having modernized ETP compared to conventional ETPs which were earlier, like fitted with API, gravity separator, fitted with old screw pump systems, etc. Now, the modern ETP, in modern ETP, TPI replaces API because TPI is a much more efficient oil water separator compared to the API one, which was only by gravity. TPI, it is also by gravity, but here there is a sludge removal method at the bottom because the tilted plates are there at the bottom of the TPI. Now to start with, the wastewater or the oily water which is generated in a refinery or in a petrochemical installation. This is mainly from tank farm, from CTBD, cooling water blowdowns, from DM plant, filtered aqueous effluent, and from main processing area, specifically from desalter, the brine, process effluent, equipment drains, backflushing effluent, sanitary effluent, paint caustic effluent, and different floor wash materials, boiler blowdown and cooling tower blowdown. So these are major sources of wastewater inside the refinery, and these are connected to the ETP through OWS, which is called oily water sewer. So it is an underground pipeline through which the sources are connected with ETP, and after receiving this oily water, ETP starts its operation. ETP is a continuous operation, and so there is requirement of tanks, holding tanks, which will accumulate all these wastewaters generated from various sources of the refinery or a petrochemical plant. And from the holding tank, it will pass through TPI or tilted plate interceptor, and from there it will be stored into a equalization pond or equalization tank, whichever is there. In some refineries it is pond, some refineries it is tank. From there, the treated water after TPI is sent to DAF, which is dissolved air flotation. And before that, before DAF, there is a flocculator where chemicals are added for formation of flocks. And after that, it goes to DAF, and from DAF, it goes to a biological section. DAF is the last point where the chemical treatment happens. There are two kinds of treatments, or more explicitly to say, there are three types of treatments. One is primary treatment, secondary treatment, and tertiary treatment. Primary treatment considers only physical and chemical methods. Secondary treatment consists of, it involves biological treatment or treatment of the oily water in presence of bacterial consortium. And the third one, which is tertiary treatment, that is the last stage, that uses ROs or reverse osmosis process to produce final reusable water. So to start with, DAP, up to DAP it is primary section, because here only chemical and physical separations are happening. After that there is biotower. So in biotower it's a trickling filter kind of thing. So here it is a secondary process, and after biotower it will go to aeration, because in air these bacteria are aerobic bacteria and they require air for their digestion. And after the aeration pond, a part is again recycled back to biotower. The bottom of the aeration pond consists of sludge. That sludge contains a lot of bacteria, so we reuse that sludge in the form of reuse and recycle that bottom bacterial consortium again till the lifespan of the bacteria. Normally the lifespan of the bacteria remains in 7 or 8 days. After aeration pond, normally in a typical configuration there remains clarifiers, primary clarifier and secondary clarifier. And after that, after the clarifiers, the clarified water is sent to filters. There is a series of filters like activated charcoal filter, pressure sand filter, multi-gravel filter, etc. And after the filter, we get the reusable water. This water can be used in fire water services. This water can be used in cooling tower and other services where water requirement is there. So our objective is to convert the OWS water into fresh water or reusable water, and through this methodology we can reduce our fresh water consumption, because water is precious. So we can reduce our consumption of fresh water through recycling, and before recycling we are doing treatments. These are the sources. Basically more than 50% of the water is SWS water. The salt or brine, it consists around 25%, and the balance part is other tank farm drains, flare seal drains, process equipment drains, and contaminated rainwater. The contaminated rainwater and the OWS, these are separate and they don't mix with each other, because if they mix with each other, the volume will be more, and then our we will require a huge capacity ETP. So our basic objective will be to separate the contaminated water channel and the OWS channel, and there should be no intermixing in between the two. The OWS part will be treated into ETP, whereas the contaminated rainwater, that will be treated into SWMS system, which is stormwater management system, which consists of one equalization pond and a TPI, tilted plate interceptor. And after that, the CRW water will become clean. So no further treatment will be required. We can use directly it into firewater services, cooling towers, and other applications. But OWS water, which is mixed with oil at a larger quantity, that needs treatment. And if we mix these two, CRW and OWS water, with each other, then the volume of ETP will be very high. And to keep the ETP capacity within limit, we have a method of segregation of these two. Now, coming to the schematic, normally, as I have told already, this is the schematic of a modern effluent treatment plant. Equalization tank. Equalization tank, the objective of equalization tank or holding tank, whatever it may be called, it is to dilute the concentration of oil. So it is basically a pond kind of thing or tank kind of thing where influents are getting accumulated and getting homogenized. After that, it is going to API separator. Nowadays, API separator normally is not required because tilted plate interceptor is there. So if TPI is there, API will not be required. So API is a first stage separation by way of gravity, and tilted plate interceptor is the modern technology in which the tilted plates get intercepted and oil get intercepted into tilted plates, and the sludge is getting separated, oil is getting separated, and water containing less amount of oil that goes to another equalization pond for another round of homogenization. From there, it goes to DAF where chemical treatment happens. A series of intermediate tanks will be there which will dose chemicals. It is an automated process. The dosing process is automated. And with the dosing of these chemicals, there will be H2O2, there will be there is a series of chemicals. A flock kind of things will be generated, and those will be scrapped off from the top of the DAF. Similarly, there will be sludge deposition at the bottom. So the bottom sludge removal, there is also a scrapper kind of thing at the bottom which moves at a comparatively slower rate. So this way we can remove sludge from bottom of DAF and oil from top of DAF separately. After that, the water goes to a pH adjustment tank, because pH is very important for the biological treatment. Biological treatment is a secondary treatment, and here we have our R&D developed bacteria which we use in all the biological towers of all the biotowers of Indian Oil. After treatment, it goes to a clarifier, and before clarifier there is obviously aeration tank, and after aeration tank it is clarifier, then a series of filters, and after that the treated water will be generated. So biological section consists of mainly biotower and aeration tank. These are interconnected And there is a provision of recycling of aerated water into biotower and from biotower to aerator. And there is also a method of recycling of aeration tank bottom, which consists of a lot of bacteria, living bacteria, because as I have told, the bacteria which we use that has lifespan of 7 to 8 days. So until and unless they are dead, they will be used. So for that there will be a circulation facility of the aeration tank bottom material into the aeration tank. So this is the total effluent treatment plan, modern effluent treatment plan, and there are three kinds of treatment. One is pre-treatment, secondary, primary treatment, secondary treatment, and tertiary treatment. The equipment are selected based upon the quality of the influent and the quality of the product, that is the treated water. So different industries will select different equipment for their purpose to be solved. Like in Indian oil, what we are using, what we are treating is oily water. But in textile industries or in steel industry, the water will be different. The contaminated water will be different in quality and obviously in quantity also. So pre-treatment involves water conditioning through screening, equalization or homogenization, oil separation, etc. And after that it comes primary treatment section, which is pH adjustment, the removal of nutrients and metals, removal of suspended solids, removal of floating oil, and after that it comes the secondary treatment one. Secondary treatment is the activated sludge process. Activated sludge process is a process in which aerobic bacteria are injected into the system and they will be given time to consume the oil, and after that the bacterial sludge will be separated. Those will be available at the bottom of the aeration tank pond. Those are recycled as well as those are disposed of after the bacteria is dead through biological thickener. There is a biothickener. It is basically a centrifuge kind of thing which will extract the last drop of water from the sludge, and after thickening the biosludge will be disposed through authorized agencies. So activated sludge process is the heart of the ETP. It consists of aeration tanks. There may be series of aeration tanks based on the capacity of the water, and there may be series of biotowers also based on the capacity. And after that it is tertiary treatment. Tertiary treatment means it is the carbon absorption, ion exchange, ultrafiltration, reverse osmosis. And after this treatment we will get two things. One is sludge, another is water. There is a further step of disinfection. One method is chlorination with NaClO2 and another is ozonation by using ozone, in situ production of ClO2 and by using ozone. So after that we will get clean water, and another part, sludge, it can be used, it can be disposed of as such after extraction of the residual water into it. And there will be other methods like incineration. There may be other methods like landfill and disposal in the ocean. But we in India normally do not dispose into ocean. We use it in the landfill, or we dispose through an authorized agency who is approved by the Pollution Control Board, state or central. The next part is volatile organic component capture, VOC capture. VOC is generated because as in ETP, the water the oily water is equalized in equalization ponds, then API, TPI, DAF. All these equipment up to DAF will have some volatile emissions. And those volatile components are captured and those are absorbed into activated charcoal, and after that the air is disposed of through a stack. So this way VOC we can capture VOC and the air will be cleaner because people are operating into ATP. So if that place is having VOC emission, so it is very dangerous for their health also. So there are standard stipulations for removal of VOC. VOC removal, uh, it is a system. VOC is a system in which there will be uh, the equipments which contain oil floating on it will have a cover, and from that cover there will be a collection header, and collection header will be routed to the activated carbon adsorbers, and from adsorber there is a VOC blower which will take out the air and will dispose of through a stack. Now coming to say, this is a very good point, availability of adequate equalization capacity. This is very important because as we see, Haldia is situated in a region where extensive rainfalls are there. So basically, if in a day it is a 0.7 mm, or it is in a day it is a 7 mm of rainfall in 24 hours, then as per the available area of refinery or the catchment area, the runoff water will be huge. It will be to the tune of 700 meter cube per hour or so. So we have to get that water collected into tanks for equalization, because we cannot throw that oily water outside the refinery because that will contaminate the entire water circuit of the region. Availability of online analyzers, as we can see, there are different stages of treatment. So there will be analyzers, oil analyzer, BOD analyzer, COD analyzer, TSS, etc. at the beginning and end of each and every step, so that we can control the operations of, say, at the API out inlet, there will be oil and gas analyzers. At the API, the oil and grease analyzers, and there will be a TSS analyzer, there will be a BOD COD analyzer. Similarly, at the outlet of API or TPI, there will be again a oil and grease analyzer, so that we can see how much oil has got separated, and accordingly we adjust our throughput. Slop and sludge accumulation. Basically, the sludge generated in different processes, like in DAF or in aeration tank bottom. In the DAF bottom, it will be chemical sludge. So those will be disposed of through a chemical thickener, and after thickening, the waste solid will be disposed of. Similarly, the aeration tank bottoms, that will be separately treated into a biological thickener, and from biological thickener, it will be again centrifuged and then disposed through authorized agents. Now, performance of biological section, it is very important of the, as I have told earlier, because it is the heart of the ETP. So the aeration, the number of agitators. Nowadays, we are not using mechanical agitators. We are using diffusers instead. So that diffuser is a pipe which goes at the bottom of the aeration tank, and air is blown inside it. So the disadvantage of this mechanical kind of agitators, what you can see in this picture, these are mechanical agitators or surface agitators. You can see the agitation by this method of agitation. There are places where aeration will not be that much efficient. the corners of the tank, etc. But if we use diffusers, retrievable kind of diffusers, then we can aerate the entire volume of the aeration tank without any low air concentration point. So basically there are two ways, one is mechanically dictated, another is diffusers. These are final polishing sections. Final polishing section means it will be activated charcoal filter, activated charcoal filter, or PSA, pressure sand filter, or multi gravel filter. There will be layers of gravels inside it. So the treated water does not contain any kind of impurities other than oil also. This is one thing, the troubleshooting, the point number one, segregation and equalization of effluent stream. As I have told already, CRWS and OWS, those are separate. Contaminated rainwater and contaminated water, oily water, those are separate, and the circuit should be different. Otherwise, there will be mixing and it will increase the volume of ATP. Analysis is also playing a very pivotal role in ETP operation, because early detection and change in quality, because the influent is coming from different sources of the refinery, and we don't know which equipment is currently draining and what is the probable contaminants of that oily water. So it will basically give a shock to ETP by various kinds of contaminants. So accordingly, we have to change our dosing mechanism, change our dosing rates, change throughput of aeration tanks, change throughput of the bio tower, and we have to take more and more filters in line. We have to take more and more API channels into line. So it is basically called shock loading. Shock loading means when we don't know what influents are coming to ETP. So to avoid the shock loads, we require the analyzers. Otherwise, we cannot detect the input streams, the contaminants available into input stream, as well as we cannot detect the performance of the individual equipment which are used into the process. Automation of slop and sludge removal. This is nowadays in modern ETPs, the slop and sludge removal system by slotted pipe schemas are used. Those are timer-based slotted pipe schemas. Those float at the top of the API or top of the TPI, and after a time of say 10 to 15 minutes, it moves in a direction so that the slots collect the oil which is floating at the top of API, and after that the slotted pipe skimmer will be in its original position. And the slotted pipe skimmer is a manifold through which it is connected to a sump, and from there the oily water is again pumped back to unit, say VCU for processing, etc. VFD controls, these are also used in feed systems, aeration tank, APIs, TPIs, dosing systems, etc. So control and corrective actions based on the analysis of key parameters. What are the key parameters? O and G, oil and grease, COD, BOD, ammonia, sulfide, phenol, perfural, then sulfides, there will be sulfites also, nitrates, etc. So these are treated through different methodologies which I have described right now. Bioaugmentation is one more thing. Bioaugmentation is nowadays used. It's called e-bioat kind of thing. Bioaugmentation. Bioaugmentation is a method through which we can augment the aeration process. Normal aeration process does not have bioaugmentation, but in bioaugmentation, it has an analyzer which will tell that the performance of the bacteria is coming down, and based on that, automatically from the storage tank which contains the bacterial consortium, bacteria will be injected into the aeration tank. So it is an automated process of bioaugmentation, This is used in most of the aeration tanks in modern refineries. At Haldia, we are not having it, but we are installing it. By 2024, we will be having augmented biological system. Now, coming to the conclusion, the purpose and objective of ETP is to reduce the effluent generation. Effluent equalization is very important to meet the consistent feed quality, proper segregation and contaminant removal through different processes: primary treatment, secondary treatment and tertiary treatment. Avoid slippage of oil to biological section. As I have told you, primary treatment is up to DAF, dissolved air flotation. After that, there should not be any oil into the system, free oil into the system. So slippage of, because that water containing free oil is going to the biological section. So biological section contains bacteria, so bacteria can die if free oil is there. So only there will be suspended oils. No free oil should be after gas or dissolved air flotation, DAF. Online monitoring and control that we have seen in timer based mechanism of oil and sludge removal, online analysis of critical parameters, minimizing human intervention by using automation, energy optimization in treatment process, meeting the treatment effluent quality consistently, and enabling recycle and reuse of treated effluents. So after this, I will go through this is the end, and after this I will go to a MCQ part where multiple choices will be given, and we will discuss the probable answers so that we can have a clear outlook of the modern effluent treatment plant and modern technologies which are used in ETPs of modern refineries. Like this one, activated sludge comprises of activated sludge. I have told you activated sludge process, ASP, is very important. It is heart of ETP. Activated sludge consists of 10%, 75%, 95% and 50% water. So the answer will be T. Activated sludge consists of more than 95% water. Generally it is 97% to 98%. Now coming to this one, activated sludge process is an example of anaerobic suspended growth process, anaerobic attached growth process, aerobic attached growth process, and aerobic suspended growth process. So basically the answer is D, because it is aerobic and it is suspended, not attached. So there are various mechanisms. Say in ASP it is suspended growth, aerobic. In tickling filter it is attached growth, because there are media and bacteria settles on the surface of the media, and then water is passed through that, like bio tower, what I have told already. That is attached growth process but not suspended, and aerobic. So bio tower is attached growth, aerobic. Aeration tank is suspended growth, aerobic. Oxidation pond is also suspended growth, aerobic. Septic tank, it is used for township sewerages, etc. It is suspended growth but anaerobic in nature. Similarly, IMHOP tanks are also septic tanks, but they have two chambers, and the bottom chamber contains sludge. Similarly, rotating biological contactor, it is also attached growth and aerobic. The next one is a parameter associated with the operation of ASP is physical oxygen demand, sludge volume index, respiration rate, chemical oxygen. There is one parameter which is called sludge volume index. In associated sludge process, sludge volume index is a very important role. What is SBI. SBI is the volume of sludge occupied in ml in 1 gram of solid. That means in the volume occupied in ml by 1 gram of solid in a mixed liquor after 30 minutes of settling. The volume occupied by sludge after 30 minutes settling. And also there is one parameter that is called FM ratio, food mass ratio, food microorganism ratio. FM ratio is important because food is required for livelihood of the bacteria, and microorganisms are required for consumption of the food. So food mass ratio, food microorganism ratio is also an important parameter. Sludge volume index is an important parameter for the associated sludge process. Normally FM ratio we keep 0.2 to 0.5. So here it is given what is sludge volume index, what I have told. Sludge volume index is the ratio of percentage of settled volume of sludge to the percent weight of MLSS in gram. MLSS, what is MLSS? MLSS is mixed liquor suspended solid. That means the bacteria basically. The bacterial consortium which is floating or which is suspended, gets suspended into the aeration tank, that is called MLSS. Similarly there are MLVSS which is mixed liquor volatile suspended solid. So these MLSS and MLVSS are very important in activated sludge process. The next one is in an anaerobic stabilization basin, which one of the following is not generated? So it is phosphine, carbon dioxide, nitrate and methane. The answer will be the phosphine, because phosphine will not be generated. Other than phosphine, CO2, nitrate and methane will get generated. So the answer is A. So coming to the next one. Which of the following tank is used for storing sludge? Very important. The options are underground water tank, fuel tank, water tank and septic tank. The answer will be septic tank. The next one, the greasy and other substances floating on the surface of sewage is termed as sludge, scum, sewage and oily water. The greasy and other substances which gets floated at the top of dash or at the top of say aeration tank, those are scum. Basically those are called scum. So answer will be B. What is a facultative pond? Facultative pond means it is an equalization kind of pond, and what happens in facultative pond, at the top layer of the facultative pond it is aerobic and at the bottom it is anaerobic. So basically two things are happening. Anaerobic bacteria are there, anaerobic bacteria are there side by side. Aerobic bacteria are at the top, anaerobic bacteria are at the bottom. So this is called facultative pond. So it is not entirely aerobic, neither it is entirely anaerobic, and the sequence is the top layer is aerobic and the bottom layer is anaerobic. The physical and chemical methods are the type of which of the following treatment? As I have told earlier, physical and chemical methods are of primary treatment of the entire effluent treatment plan. It consists of equalization pond, API, TPI, then again equalization pond, pH adjustment tank, loculator and dissolved air flotation. Up to this, it is physical and chemical methods. After that is the biological method. The biological method is the type of which of the following treatment? It is secondary one, and the RO treatment is the tertiary one. The function of primary clarifier is to remove suspended heavy particles from the raw effluent. Yes, it is true. Secondary clarifier, it separates finer particles, and primary clarifier will remove suspended heavy particles from the raw effluent. Similarly, which of the following is required to transport storm water runoffs from roofs, parking lots, streets, highways to a point of discharge? This rainwater, this is called storm water basically, storm sewers. Through storm sewers, the storm water will be transported to the point of discharge. And before discharging, it will be treated. There will be one equalization tank and then TPI, tilted plate interceptor, and after that, it will go to the users. It will be fed to cooling tower or the end users in refinery for the reuse and recirculation and for reduction in freshwater consumption. So answer is storm sewers. Lamellar clarifier is also called an inclined plate stapler. Lamellar clarifier is a modern technique. In normal clarifier, it is basically a tank kind of thing with a scraper at the bottom and scraper at the top. The bottom scraper that collects this sludge to the bottom of the clarifier, and because there is this clarifier bottom, as you can see the aeration tank bottom. Similarly, clarifier bottom also contains some amount of bacteria because clarifier is just after aeration tank. So clarifier bottom will also have some bacteria which can be recycled or reused. So lamellar clarifier is called inclined plate settler. Normal clarifiers are not having inclined plate settlers, but in lamellar clarifier it is inclined plate settlers are there. Like it is a picture of the lamellar clarifier. There are inclined plates and through which this sludge gets accumulated at the bottom, and from there it is getting discharged to the sludge disposal area. And at the top is the fresh water, which goes to multiple filtration like multi-jet filter or multi-gravel filter, activated charcoal filter, or pressure sand filter, etc. So lamellar clarifier is a modern clarifier. Normal clarifiers are not having tilted plate settlers at the bottom. Lamellar clarifiers are having tilted plate settlers at the bottom. Normal clarifiers, they have a scraper at the bottom, which is a rotating scraper at the bottom to scrap off the sludge, and at the bottommost point, the sludge is transported through a pump to the sludge treatment area. What does the performance of a dissolved air flotation depend on? The performance of a DAF, it depends upon air to solid ratio. So the answer is A. 2000 into 1000 by 1000 by 1000. So in kgs. So it will be around 800 kg per day. Now biomass requirement will be BOD load by food to microorganism ratio. BOD load is 800 and food to microorganism ratio is 0.15. So 800 by 0.15, it is around 5333 kg. Now it is given that MLSS is 3500 mg per liter. So it is basically 3500 into 1000 by 1000 into 1000 divided by 10 to the 6, that is 3.5 kg per meter cube. So the volume of the tank will be biomass by MLSS. Biomass is 5333.3 by MLSS is 3.5 kg per meter cube. So 5333.3 kg by 3.5 kg per meter cube equal to 1524 meter cube. So say A is the answer, 1550. So with this, I am ending this ETP part. Now coming to the next part, which is hazardous waste management. Hazardous waste management means hazardous waste storage, treatment, and disposal. You open the presentation. Is the presentation visible?
Yes, sir, it is visible.
So before moving to the this part, there will be some terms which will be required. One is authorization. Authorization means permission for generation, handling, collection, reception, treatment, transport, storage, reuse, recycle, recovery, pre-processing, utilization, including co-processing and disposal of hazardous waste as per rule number 6. So authorization, what is authorization? Authorization means permission. So these are the terms which will be used into the presentation. So that's why I am just summarizing the terms. One is co-processing. What is co-processing? Co-processing means disposal of sludge to using in other processes, say in cement industries or in other industries. So co-processing means use of the waste material in manufacturing processes for purpose of energy or resource recovery or both, and result in reduction in the use of conventional fuels for raw materials or both through substitution. So co-processing is basically substitution of fuel with the sludge. Disposal means any operation which does not lead to reuse, recycling, recovery, utilization, including co-processing, and includes physico-chemical treatment, biological treatment, incineration, and disposal of the disposal in secured landfill. Another word will be used, that is hazardous waste. Hazardous waste means any waste which by reason of characteristics such as physical, chemical, biological, reactive, toxic, flammable, explosive or corrosive that causes danger or is likely to cause danger to health or environment, whether alone or in contact with other wastes or substances. There will be one term, occupier. Occupier means it is in relation to the factory or premises. It means the person who has the control over the affairs of the factory or the premises, and includes in relation to any hazardous or other wastes the person in possession of the hazardous waste or other waste. So occupier means the top or the plant head. Manifest. Yeah, this is a very good term. Manifest means transporting document which is prepared and signed by the sender, authorized in accordance with the rules and regulations. Then there are terms like recycle. Recycle means reclamation and the processing of hazardous waste in an environmentally sound manner for the originally intended purpose or for other purposes. Reuse is different. Reuse means use of hazardous waste or other waste for the purpose of its original use or other use. Recovery is also a good term. Recovery means any operation or activity wherein specific materials are recovered through different processes. Then there is a term called used oil. Used oil is it is generated mainly from transformer and various rotary equipment. This is disposed of to oil recovery pit or further reprocessing along with slop oil. Spent catalyst means the catalyst which is after the end of run condition. That means that has to be replaced. Its efficiency has come down. That is called spent catalyst. Spent catalyst also comes under the hazardous waste category. Spent adsorbents are also there. It is generated in processes and from DM plants. It is disposed of to approved TSDF site. TSDF means what
Sir,
is
sir, I am interrupting you.
yes.
Just sir, your slide is not changing.
No, slide will change because I am
Okay.
defining terms. After
Okay.
that, the slide will change because
Okay.
in this slide there are few terms which are not known to.
Okay. Okay, sir.
which requires explanation. So spent adsorbent, TSDF. One is TSDF. TSDF means this term will be there: treatment, storage, and disposal facility. Now moving to the slides. So basically in this presentation I will cover highlights of refinery in the perspective of environment protection, sources of hazardous waste generated in the refinery, storage methodology, processing and disposal of oil sludge, disposal of hazardous waste other than oil waste, and new initiatives taken. The refinery is having four numbers of sulfur recovery units, and apart from that it is having sulfuric acid plant also, which is unique among all Indian oil refineries. So for emission reduction, this refinery plays a pivotal role amongst Indian oil refineries because it is having SRU and sulfuric acid plant simultaneously in parallel. This refinery was commissioned in January 1975 with a capacity of 2.5 million metric ton per annum, and from there it is augmented to 8.0, which can be extendable up to 8.5. And this refinery produces lube oil base stocks. So these are important because these will indicate the amount of hazardous waste which is getting generated and the safe disposal of the hazardous waste so that it can be as per the rules and regulations of the Pollution Control Board or the authority. To treat the effluent, we have two numbers of ETPs. One is of 600 meter cube per hour, the another is 650 meter cube per hour, which is getting augmented to 850 meter cube per hour. So basically present capacity is 1250 meter cube per hour, and another 250 meter cube per hour is getting added. So after that it will be say 200 meter cube per hour is added. So after that it will be 1450 meter cube per hour ETP, combined ETP 1 and 2. Now coming to the sources of hazardous waste generated from the refinery. So the left column, it is description of the hazardous waste. Hazardous wastes are oily sludge, residual sludge, spent catalyst, spent adsorbent, spent sulfur guards, waste mineral wool containing oil, that means oil soaked insulation, spent ion exchange resins, used RO membranes, and waste refractory bricks. These are the broadly, there are 6 categories of hazardous waste. And the sources of generation are oily sludge, those are from maintenance, or while we are doing maintenance of crude tanks or maintenance of heavy oil tanks after a time period of 10 years, then we found a lot of sludge at the bottom which contains more than 10% of oil. Similarly, there are residual sludge which are having less than 10% of oil, which is like the bio sludge after the biothickener and centrifuge, and the chemical sludge from the bottom of that to a centrifuge, chemical thickener and centrifuge. So these are containing less than 10% weight oil. Similarly, spent catalyst, spent adsorbent, and spent sulfur guards, these are used in processes where hydrotreatment or hydroprocessing or hydrocracking as well as catalytic processes are there in this refinery. So these hazardous wastes are getting generated from those processes. Waste mineral wool containing oil, that is oil soaked in insulation, oil soaked into insulation. These mainly the tank farm and process units are the sources. Similarly, spent ion exchange resins and used RO membranes, these are from water treatment plants, the tertiary treatment plant, or TTP what we are calling. Similarly, waste bricks, refractory bricks, these are from process furnaces. So these are basically the sources. and these are the storage facility on temporary basis. The corresponding hazardous wastes are stored like oily sludge. It is stored in RCG HDP line pits. Residual oily sludge containing less than 10% weight oil, 10% weight oil. Those are also kept into RCC HDP line pits. Spent catalysts, spent adsorbents, spent sulfur gas. These are basically stored in metallic drums or super sacks. Waste mineral wool containing oil. These are stored in super sacks or at a dedicated yard, uh, separated from the water circuit of the refinery. Spent ion exchange reagents. These are stored in metallic drums or super sacks. Waste refractory discs. These are also kept into super sacks. This is the simplified flow chart of processing and disposal of oil sludge. Oil sludge from refinery tank maintenance, oil sludge from ETP oil treatment section, and oil sludge from melting pit. So these are treated through separate processes respectively, like oil sludge from tank M&I, this is by mechanized cleaning, oil sludge from ETP by centrifuge operation, as I have told you, biological thickener, and after biological thickener and after chemical thickener. There are centrifuges which will further extract water or oily water from the solid sludge, and then the sludge is getting disposed. Similarly, oily sludge from melting pit, this is sludge processing by external agency. There are agencies who are doing this kind of jobs, so we can outsource them also. So after this, we will get recovered oil. This will be used for reprocessing in billet coker unit or in crude tanks. And the sludge, this will be disposed through an authorized agency of West Bengal Waste Management Limited, like WWM, and co-processor. Co-processor means cement industries or power plants, etc., who will use that sludge into their processes for reduction of their fuel consumption or in other processes. So oil sludge generated from TPI gaps, stormwater ponds and guard ponds in effluent treatment plant and from tank or M&I bottom. These are the major sources of oil sludge. Processing of oil sludge. How do we process the oil sludge? Sludge processing unit, we have outsourced the units, and what they are doing, they are having their own centrifuge, and into that centrifuge they put that oily sludge, and after that what solid is getting generated, that part they are storing into super sacks and then disposing it. Another option is processing of oily sludge is processing in billet coker unit. And the third one is processing along with crude, reprocessing along with crude. The processing of slop oil or sludge into delayed coker unit is called co-processing. And the removal of water or oily water from the sludge, that is a separate method in which sludge will get generated. That sludge can also go to co-processing of other industries, and the oil which gets separated or oily water which gets separated, that will be returned back to the refinery. So this is a typical flow diagram of oil sludge processing. There are four stages of separation. First stage is heating, second stage is separation, mechanical shakers, third stage is separation, hydrocyclones, and the last step is centrifuge. So after that, whatever solids are getting generated, after stage 2, stage 3 and stage 4, those will be sent to authorized agencies, and the liquid, it will be again treated into ETP, or it can be co-processed in issue, or it can be used in other processing. So these are the pictures of the sludge processing modular sludge processing units, which have been outsourced at Haldia. The sludge processing unit called SPU, there are 4 or 5 vendors available who are doing this kind of things. Those are authorized agencies of the West Bengal Waste Management as per the West Bengal Waste Management Authority. These are few pictures of the plant. STC. So we are also using that method. We put that sludge quantity into auction, and the H1 bidder who quotes the maximum amount or which is higher than the desired price, those have been given the work order. So these are the super sacks. You can see the catalysts have been kept into the super sacks so that we can avoid spillage of the catalyst as well as ease of disposal through trucks. These pictures, these are super sacks in which sludge has been kept and it is ready for disposal. This is residual sludge containing less than 10% oil. New initiatives in last 2-3 years we have taken few initiatives because we had a legacy sludge which was to the tune of 5,000 metric ton or so. So to dispose of that amount of sludge, we took 3 methodologies. One is sludge disposal through agencies, another is landfill, and the third one is e-auction. So these are the new initiatives we have taken to dispose of our legacy sludge, which was lying in refinery for a long period of time. So that's it. I hope we have covered almost the ETP part and hazardous waste management, storage and disposal part. Because of paucity of time and refinery is under shutdown, so I have to go to plant also. So with this I am ending this. Thank you.
Thank you so much, sir, for sharing your knowledge. I hope our participant will be benefited a lot from this lecture. Now, no, there is no question from the participants. No question. Then thank you once again, sir, and thank you so much.
Thank you very much.
Thank you.
Very yeah.
Now, dear participants, with this we are ending today's session here. Tomorrow we have our second day of FBP. The permanent inaugural session will be from 3:30 p.m. Technical session will be started as per the schedule. In technical session, the speaker is Mr. Asit Mitra, Deputy General Manager Manufacturing at Haldia Petrochemicals Limited. He will be giving his lecture on petrochemical industry wastewater treatment and management and sustainable development towards global environmental protection. Now, dear participants, attendance link is live and it will be active for half an hour. So please mark your attendance within half an hour. Thank you everyone. Once again, thank you. Have a nice day.